Hello everyone, welcome to CAD/CAM CA tutorial point. Today I am going to show how we can do the static structural analysis in the ANSYS software. This is mainly the finite element analysis, the basic concept. If you have the basic concept of the finite element analysis, then you can easily understand how the gear meshing. Today our first assignment is the static structural analysis. That is the first problem statement. That is there are the two spur gears, one gear 1 and another is gear 2. And for the problem statement is we are going to apply moment and the rotational velocity in this gear. This is the driver gear, okay, and this is the driven gear, okay. And this will be still, this has the fixed support in this bearing section. There are in their part there will be the fixed support, and there is we at first we have apply the moment and then we will apply the rotational velocity here. So let's open our ANSYS. Okay, so we are coming to the ANSYS Workbench option, we all know. So here we have to first double click in the static structural part. Then this is the engineering data. The material of the gear is constant, that is the structural steel, and we all know that automatically here the structural steel is selected. Here the structural steel is selected. I am not going to change this anymore. And then we have to import the geometry. So at first you have to click here the right click of button, then the import geometry, then you have to browse it. So here previously I have made one gear assembly, and that is in the IGS file. Then so I have to import that file also. And in my channel I will make another video how to make the gear assembly in after this video. So select this, there became the tick mark. I am not going to change any dimensions or the geometrical change here. So directly we can go to the model section, double click here, then here one start mechanical option is starting. The mechanical workbench is going to open. It needs some of times, so we have to give it some of the times, so please wait. It takes some minutes. Okay, this had been open. My geometry has been open. Okay, let's see this like that. Okay, now we have to, at first you have to make the meshing. Okay, you have to first make the mesh. So first right click on the mesh and click generate mesh. Automatically the mesh has been done, and in other video in the advanced section I will teach how to make appropriate meshing. Now this is enough for the beginner stage. Okay, you have generate the mesh, the small portion that's all included, that's called the meshing. Okay, how much a good mesh you can generate, the more specific result you will get. Now you have to go to the static structural part, then go to the insert and click here the moment. What is the moment? Moment. Okay, here we will give the moment. At first select this face option, that it will get the surface only, then zoom it, select this, press Ctrl and select the another part, that be maybe this, that maybe this. Okay, click here the vector. Now I define by vector, I will go for the component, that is the component. Here the x-axis I will give the 100 Newton. Okay, 100 Newton moment will be given here. Then click here, then click here, then go to the then the static structural part second time. Here insert, and now I go for the fixed support. The fixed support, here the fixed support will be given. So face will be selected, select here, control here, here. Okay, the face will be selected here, the face will be selected, and okay. Now we will go for the solution. Now I have again make the moment and fixed support again. So at first I will go for the static structural, insert, moment, select this face, press Ctrl and select this face and this face, click here, apply, then go for the component, x component 100 Newton. Okay, done. Then go for the static structural, insert, fixed support, then go for this face, click here, control, click here, control, click here, apply these faces, fixed support, done. Now I have to go for the solutions, right click, insert, deformation, total deformation, then solution, insert, stresses, click here, equivalent von Mises stresses. Okay, then go for the solution, insert, that is equal to the contact toolbar, click here, then for the contact tool, here this should be contact side and contact selection. Okay, and click here, insert, pressure. Okay, as before I have taken one, so I have to end it. Okay, insert, pressure. Now I have to delete this. Okay, and then this is the machine. Everything has been done. Now I double click in the solution, go for the solve. Please wait some time for the solve portion. But what the machine? I think there is some problem in the machine. Now in the solution, in the total deformation, that is the machine. What is total deformation? Click here, and in the meshing view, if we see, how can I make the meshing view? Display, now just go for the here display, here the meshing has been done. Okay, this is the deformation. You have seen this has a deformation. This is the contact pressure area and its value here, and the equilibrium stresses here. Now I will give the air velocity, rotational velocity here instead of moment, and it will be the fixed support. So I have to end this. I have to end this also. I will give here the rotational velocity, and then will be the fixed support. For the rotational velocity portion, double click in the static structural geometry. Now import the geometry, that is the assembly. Now go for the model. Now the mechanical window is going to open. Please wait some time because this is a big software, so quite time will be taken here. Now the window has been open. And the window has been open, and this will be become. Now I'm go for the again for the meshing. Click here, meshing, insert, click here, mesh, generate mesh. The meshing has been done. Now go for the static structural, insert, that is first for the rotational velocity. The rotational velocity, click here this and this face and select another face and this is a 100. For why the face has been not selected, click here and click here, should be selected. Here I have to at first delete it, then static structural, insert rotational velocity. This is the driver shaft, so select this face and select the another face, go for the vector. I will go for the component, select 100. Okay, and this has been done. Go to the static structural, insert and the fixed support. The fixed support will be here and here, control here. This will be the fixed support. Okay, now go for the solve. It's solution. Now go for the solution, insert deformation, total deformation, solution, insert stresses, equivalent stresses, solution, insert contact tool. Here this should be both and the all contact tools. Right click here, insert pressure, it will be the contact pressure. Now solve. Okay, done here. So at first here the total deformation has been done. I will yes, okay. Now this is the deformation, total deformation. We will give here the angular velocity, it will be the fixed. I think that this gear pinion, this is the pinion, will be the fixed portion, and this is the driver shaft, this is the driven shaft. For this angular velocity of the teeth, as it there the angular velocity is given, it also generate in the teeth portion, so there will be one deformation. If we make the animation here, please see the deformation will be doing here. Okay, the deformation will be doing here constant, and there is the equivalent stresses. Make the animation, there are the equivalent stresses has been done. Okay, and the contact pressure, here will be the contact pressure will be happen, here is the contact pressure will be happen, and again the total deformation, here will be the deformation will happen, here will the deformation will be happen. As I am going to give here the angular velocity, so the total deformation will be given. If we change this rotational velocity, delete it, and the fixed support. So if we again give here the two things, what is going to happen, please see. Insert fixed support, this will be the fixed support, this fixed support, control here, apply. Okay, done. Static structural insert, give the rotational velocity here, control here, vector, that will be the component 100. Okay, done. So if we again solve, what will be done? Please see. Now the solution has been opened. Please go in the solution, deformation, click here. Here see, now this is going to rotate. This will be the fixed support, so this has been doing here. Okay, for the fixed support, this has been doing here, and this is the equivalent stresses here. And for the contact tool, contact pressure, there will be the contact pressure will be generated. We can get the value from here, and in this way we can make the static structure analysis. Thank you.